Okay, so for our next trig function, we have the limit as theta approaches 0 of tangent theta over theta. So if we go ahead and try to plug in that 0, we can see from the denominator it's not going to work. So we're going to rewrite, because that would be our next step here. And we know we can rewrite tangent as, let me do this, sine theta over cosine theta. Now I do notice nothing's going to cancel here, but we can try to do same change flip. So we're going to end up with sine theta over theta cosine theta. So we can try to do the limit now. Just see what happens. So we'll have the limit as theta approaches 0 of sine theta over theta cosine theta. So if I plug in 0 here, well, look, we have another 0 in the denominator, so that's not going to work. Alright, so direct substitution is not going to work there. So we're going to have to come up with some other option. So think about the things that you need to memorize. How we had that sine of c theta over c theta. And that would always give us 1. So if you look here, we can actually see how we have sine theta over theta. That would be that property there. So we're going to split this into two limits. We're going to make this the limit as theta approaches 0. Let me kind of get this to stop being so blurry. So we're going to split it to the limit as theta approaches 0 of sine theta over theta times the limit as theta approaches 0 of 1 over cosine is what we have left. Okay, so even though it looks like, yeah, you can't do direct substitution, but we know from the property from before that sine theta over theta, as long as the limit is theta is approaches 0, it's always going to be 1. So that answer is 1. And then we can do direct substitution here. So 1 over cosine of 0. Well, think about your unit circle. At 0, it's 1, 0. Well, cosine is going to be 1 there. So it's going to be 1 times 1 over 1. So our answer is going to give us 1 there. So moving on to number 6. So before we start this one, another trig identity that you're going to use a lot is sine squared theta plus cosine squared theta is equal to 1. So we're going to need that in this problem. So what we're going to do first, we have the limit as theta approaches 0, so we want to try to do direct substitution, but you see we have that 0 in the denominator. So our next step is always to try to rewrite. So to rewrite here, I'm going to factor out a GCF of 2. That'll leave me with 1 minus cosine squared theta over theta. Okay, well, if I rearrange this Pythagorean identity here, if I subtract over this cosine squared, that means 1 minus cosine squared is going to be equal to sine squared theta. So I can rewrite this 1 minus cosine squared here as sine squared theta. So this is the same thing as 2 sine squared theta over theta. So I just used the Pythagorean identity there. So now that we've done that, we can come over here and we can do the limit as theta approaches 0. Well, that theta is still in the denominator, so that's still not going to work. Okay, so if it doesn't work, remember like on number 5, we split this into two limits. So we're going to try that. Okay, so remember the one that you had to memorize and over here on number 5, when you have sine theta over theta, that always gives you 1. Well, if we can take out a sine here, over theta, that'll get rid of that theta, and then we won't have to worry about that 0 in the denominator. So I'm going to make limit as theta approaches 0, and I'm going to do 1 with sine theta over theta, because I know that works and turns into 1, times the limit as theta approaches 0. Because I took one sine out in the numerator, I'll still have 2 sine left in the numerator. And I've already gotten rid of the denominator, so there's no denominator over here. Okay, as long as when you multiply these two things together, you end up with what you have. So then we know that the limit as theta approaches 0 of sine theta over theta is 1. And then we can use direct substitution over here. Okay, unit circle at 0. Sine would just be 0. So this is going to end up giving us 0 for answer here. Okay, so for 5 and for 6, we tried to do direct substitution. Didn't work, so we rewrote it some way. Here we had to use the Pythagorean identity. Tried to do direct substitution again, but that theta was still in the denominator, so it didn't work. So if we split this into 2 limits, making one of them be sine theta over theta, that gets rid of that theta in the denominator, and we know this is equal to 1, and then this other part we can do direct substitution on. Okay, so looking at number 7. Alright, we want to try to do direct substitution first, but like the rest of these, we've had 0 in the denominator, so we can't do that. Because these are already in terms of cosine and sine, there's not going to be any way to rewrite this. So no trig identities. If it was cosine squared or sine squared, then we could use that Pythagorean identity. Because it's cosine theta, and this is actually sine 2 theta, we can't do that. So we're going to go ahead and skip to that rewrite. So I'm just going to write rewrite, but we couldn't do that. So now we're going to go to the split into 2 limits. Okay, so the difference between this problem and the other problems was that we were working with multiplication. If we want to split this up, we're going to have to use, because I'm going to split 1 minus cosine theta into one part, and then 2 sine theta into the other one. Okay, the goal was to get, your sine theta over theta, so I want to put this with the theta. But because there's addition between here and not multiplication, then we're going to have to make sure we do our fraction. So I'm going to, before I do the limit, if I want to make this a true statement, we would do 1 minus cosine theta over theta plus, then the other fraction would have to have sine 2 theta over theta. Okay, so this is a true statement. When I add fractions, I have to have the same denominator, theta, and then I can add the numerator and it'll be all one thing. Whereas, like on number 6 here, when I had 2 sine squared theta, when I took these out, they were just multiplied, so they didn't have to have the same denominator. Okay, so that's the difference. Okay, so now I got the limit as theta approaches 0 for each of these. Okay, so for on the left side here, now it looks like I can't do direct substitution here, but if you remember and you look at the ones that you memorized when we haven't really used, the limit as x approaches 0 of 1 minus cosine x over x will give you 0. Well, that's what we have here. Okay, so you couldn't do direct substitution, but this gives you 0 from those properties. So you have 0 plus. Okay, over here on the right side, it says sine of 2 theta over theta. So remember, for this to work, there has to be a 2 in the denominator. So we're going to put a 2 in the denominator, but if we put one there, we also have to put one in the numerator. So I'm going to go ahead and bring that 1, 2 out front. So that I'll lose with sine of 2 theta over 2 theta. So we're going to have 0 plus this 2, and then we know that this sine of 2 theta over 2 theta for that limit gives us 1. So when we add those two thetas together, we do end up getting 2. Okay, so for the trig functions, you're going to try direct substitution, then you're going to try to rewrite. Sometimes once you rewrite, then you can plug in and that's it. If you can't rewrite it, then you might have to split it into 2 limits, making sure that you look for the ones that are going to help us out. So the sine of x over x gives you 1, and the cosine of x minus 1 over x, and 1 minus cosine x over x gives you 0, as long as your limit's approaching 0 there.